Okay, it's time for another example. So let's see what we can do here. As you can see, this is three-dimensional, x, y, and z, clearly indicated here. Volume bounded by paraboloids, two paraboloids. Z equals 2 times x squared plus y squared, and z equals 12 minus x squared minus 2y squared. So the first thing we need to do is find our intersection points and our boundary point. That's the first thing we need to do. So let's see where these things are bounded. Okay, when z1 equals z2, as we can see, they do cross, so that will give us ending points. So let's set these equal to each other, and let's solve. Okay, we get 3 times x squared plus y squared equals 12. Okay, so this x squared plus y squared equals what? R. Yes, I'm glad you noticed that. Okay, so now if we divide everything by 3, now look what we got. R squared equals 4. So what does R equal? Aha! When they hit this point, R equals 2. Okay, note, when R equals 0, okay, so it's at the top and at the very bottom. Okay, when R equals 0, we have Z equals 12, which is up here, as you can see. And I'm trying to find this, okay, and then down here we have it cutting across and it equaling according, okay, so we solve for it. It says that R equals 2, and we can see right here for ourselves, at Z equals 2, that it is also at 12. So now we have 2 points. Wonderful. So, and we have 2 points for R. So we see when R dz, so z1 to z2, we have from 0, R equals 0, and R going to 2, as we found out. And we have the angle, it goes from 0 to 2 pi, a complete circle. Okay, so we looked at z1 minus z2, and now we're going to do also, we could look at also z2 minus z1. Okay, you're saying, why do I'm interested in z2 minus z1? Okay, let's find out. Okay, we have this volume, we have our limits. All we do is plug them in. So this goes from z2 to z1 here for z. And so now we can solve for z2 minus z1, which is 12 minus 3r squared. So we're going to take this 12 minus 3r squared and plug it in. Okay, right into here. And then we're going to look at for our integration again. But now if we use that, we need to multiply r times everything because we're doing a dr. Okay? So with this dr, we see that this is be 1/2 r squared. Half of 12 is 6. Then we see here it'll be 3/4 minus 3/4 r to the 4th power. We're evaluating this from 2 to 0. When we evaluate this from 2 to 0, And we also looking here at d theta. That just goes from 0 to 2 pi, so it's just going to be 2 pi. And if we plug in 2, and 0, plug in 0, we know everything will drop out. We plug in 2 here, we get 2 squared, which is 4. 4 times 6 is 24. We plug in 2 here, raise that to the 4th power, multiply by 3, divide by 4, and we get minus 12. We subtract 12 from 24, we get 12, and 2 pi times 12 is 24 pi. So that's our volume. Okay, so look at this so that we might be able to understand the 3 dimensions and how do we pick our limits. Remember, the boundary points are very important. So let's see. I think we have one more example we want to do. I want to pause on this one because this last one was going to take a long time. So, since it's going to take a long time, let's take a pause at this point.